All right, here we are with chapter 3 of the textbook, Light and Color. Light. We will be discussing the visible spectrum, value and contrast, value pattern, and chiaroscuro. The visible spectrum. Light is a natural agent that stimulates sight and makes things visible. Light is energy that we can see. And I'm talking scientifically, but I'm trying to speak about it in artistic terms as well. If you've ever seen a prism, which is sort of a glass, like a crystal glass, maybe a triangle or a pyramid, you might have seen that it has the ability to split white light from the sun into a full rainbow. These are all the colors that in the rainbow, these are all the colors that we can see. These colors are considered the visible spectrum. We see color because there is light. Without light, there is no color. Now let's step back a little bit. Color, does the rainbow, if you've noticed, doesn't have black on it. And it doesn't have white on it. We see white here. So white is light and black is the absence of light. So when you're talking about black and white, the terms that we use are value and contrast. So value can describe a color, but it is a property of white and black, not a property of color. That may sound confusing, but imagine taking a black and white photograph of an object. All of the color that would have been in the image is then black and white, and it becomes shades of gray. If you have a dark red, a person wearing a dark red shirt standing next to a person that's wearing a bright pink shirt, those are both red shirts. But if you take a black and white photo of those two people, you'll see a darker gray and a lighter gray. And that difference in gray and the black or white, that is value. Value is a description of lightness to darkness as it relates to a color or a surface. Contrast is the degree of difference between shades of gray. Drawing objects or figures with a high value contrast make them easy to see. Okay, so value, again, a description of lightness to darkness as it relates to a color or a surface. So what is the value of this area? Well, it's close to white, so it is a light value. The value of this is a dark value. This is a low value. And the difference between this dark, I'll call it black. It's not quite black. The difference between the black and the white is a high difference, a big difference. The difference between this square of gray and this square of gray is not a very big difference, but there is a difference. So what contrast is the degree of difference between shades. So we can look at this painting and we can see that there are 1, 2, 3, 4 steps between black and white. So you can call that 4 degrees of difference. But between these colors or these values, there is only 1 step of difference. So that is a lower contrast. Black and white, higher contrast. Value is the amount of gray or black in an image or an object. And it's disregarding the color. The value pattern describes the variation in light and dark within a work of art and the ways in which they are arranged in a composition. So value pattern is describing the artwork in terms of where the lights and the darks are in the artwork. This image is of a single painting. Imagine doing the painting, and what it says here, painting on linen, 2 panels. So it's a single artwork with 2 panels that are pushed together. So if I were to describe the value pattern of this artwork, I would say that the left side is high contrast. There's black and there's white, or something close to it. On the right side, I would say that it is low contrast. The difference between the lightest light and the darkest dark is not as extreme. They're pretty close together. So again, describing the value pattern of this artwork. The artwork is divided with a left side and a right side down the middle. The value pattern is high on the left, and it is low on the right. Chiaroscuro is an interesting word. It's thrown in here because I like it. But chiaroscuro is the gradual progression from light to dark through a successive gradation of tones across a curved surface. Basically, this is a style of painting that was popular during the Renaissance, during the later part of the Renaissance. So here's the artist Caravaggio, and he was known for using the technique of chiaroscuro. The darks are very dark and the lights are very light. The figures are always tend to be cast in an extreme shadow. That's chiaroscuro. This is an interesting artwork that I threw in here by the artist James Turrell. So what are we looking at? We are looking at a projection of red light projected right into the corner of a room. So this is different than a painting. It's different than a drawing because this art is working with light and light alone. I threw it in here to transition us to more conversation about color. So we will talk about additive color, subtractive color, the color wheel, hue, intensity and saturation, color schemes, analogous color, complementary color, local and optical color, and arbitrary color. I do have to warn you, I find additive color interesting, but it blows my mind, and I cannot specifically talk to the science of it. But we will cover it a little bit. So, like I said before, you can take white light, shoot it through a prism, and it comes out a rainbow. Well, you can take red, blue, and green, and you project it onto a wall, and together that makes white light. Red and green, for some reason, mix together to make yellow. Again, it blows my mind. Red and blue mix together to make something that looks like purple or magenta. Blue and green mix together to make a light blue. That would be maybe called cyan. Additive color is in stage lighting, and it's also in your computer screen that you're looking at. There is an old TV. You might remember this kind with the big old pixels. We're looking at red, green, and blue. So they're all next to each other. And depending on how much red or how much blue or how much green is in each pixel is which color we see. So additive color is called additive color because you're adding color to the visual spectrum. So you're introducing red and you're introducing blue, and you're adding color. That's actually different than using paint, which is subtractive color. So consider this being paint. When you mix pigments, you are removing light from the spectrum that you can see. So colored objects tend to absorb, like a red object will absorb, yellow and green or yellow and blue, and it will reflect red back to your eyes. That's subtractive because it's, again, removing color from the spectrum. Mixing pigments. As you can see, we have a reddish color. Like I said, that object is absorbing blue and yellow. I would say it's absorbing more yellow than blue in this instance because I see a little bit of blue coming through. There's yellow. it seems to be absorbing red light and blue light, and you get yellow. This is something I don't understand. But if you use the colors cyan, magenta, yellow, and black to make a print like in a magazine, and you look really close, you see a bunch of dots that just lay over top of each other. That's also subtractive color. Alright, but this I do understand. This is the color wheel. I'm sure you have worked with color wheels in the future or in the past. Let's do some definitions here. Hue, H-U-E, is a fancy word for color. It is a more scientific approach. I don't mind if you use hue or if you use color when you're describing color. But hue is the fancy word. So primary hues or primary colors are colors that just exist. They simply exist, and you cannot mix any color together to make those colors. So we have yellow, we have red, and we have blue. These are all labeled as P for primary. Secondary colors lie halfway between the primary colors, and you mix the two primary colors to make the secondary colors. Yellow and blue make green. That is a secondary color. Yellow and red make orange. That is a secondary color. Red and blue make purple. That is a secondary color. Tertiary colors are secondary colors mixed with primary colors. So purple and blue, or violet and blue, make blue violet. You always say the primary color first when you're describing a tertiary color. Yellow and orange make yellow-orange. Orange and red make red-orange. Tertiary colors, again, are mixed between secondary and primary. I want to talk about analogous colors. Artists will use analogous colors often. Analogous colors are all of the colors in the family of a single color. So, analogous to red. Well, where is red? Red is here. Where is blue? Blue is here and yellow is here, okay? So, colors that are mostly red. We have red violet, and we have, well, it's halfway, but violet. And then we have red orange and orange. These all have significant red values in them. So those are red. Well, you can have colors that are analogous to secondary colors. So we can also have colors in the family of green or orange or violet. So a family of colors with green or analogous colors would be colors that are in green. So green is made of yellow and blue. So from blue to yellow, those are analogous. We have blue, blue-green, green, yellow-green, and yellow. Those are all analogous to green. At any spot on the color wheel, you can move this line that I drew on here. You can shift it to whichever color that you want, and then those are the analogous colors to any particular color. Complementary colors. Complementary colors, if you look at your color wheel, are opposite of each other on the color wheel. So blue and yellow are complementary. Orange and blue, purple, yellow, orange, blue, red, green. Complementary colors are really popular in design throughout, history. What do we recognize red and green as immediately? Well, that would be Christmas colors. They're also really popular in sort of athletic designs, so sports teams. So purple and yellow, what would that be? That might be the LA Lakers. How about blue and orange? I don't know, the Chicago Bears, maybe? Color schemes such as complementary colors are important because they sort of clash with one another and they tend to make each other pop in a vibrant way. That's why you see them in a lot of designed images. So this is supposed to talk, with this image I want to talk about the difference between value and color really fast. Remember, I was saying earlier that value is lightness to darkness. So here we have white and we have black and we have gray. Lightness to darkness. That's value. Well, that's the same as on this side. White to black. You see yellow to black, but if you were to take a photo of this in black and white, this would appear as white in the top corner, black in the bottom right. White to black. Well, this image also shows something called saturation. So we have saturation, meaning very vibrant, very intense color. We have yellow to white. So you have white to black, yellow to white. This is a saturated color here. This is no saturation, no color. This area is, halfway between yellow and white. Right in the center is sort of a grayish yellow. Over here is a highly saturated yellow-gray. This is value. This is saturation. Back to this painting. Cool colors. Cool colors are colors defined on the green-blue side of the color wheel. So We have lots of greens, we have lots of blues. They feel cool. If you look at a giant painting, mind you, this is a giant painting in real life, but if you get up close to it, it might actually make you shiver. They are cool colors. You associate winter with blue in particular, or green, or being cold. Warm colors are colors that are red or yellow in the color wheel. So this is a woman in an opera house, and she is fanning herself off. I assume it is hot in the opera house, but it feels way hotter because of the choice of colors. Interesting is that this is a green fan, and there is green in her shirt. I don't think that this means that it is a hot and a cool environment. This is an instance of the artist using complementary colors. So mostly red and yellow, warm environment with a complementary green. Green being the opposite of red on the color wheel. Local and optical color. Local color is the actual color of an object. Optical color is the perceived color of an object. Optical color is largely dictated by a surrounding color field or an environment. So my question for you is, how many colors do you see in this artwork? You may intuitively know the answer, but your brain may be saying something different. Look at this artwork closely. We'll call this violet and we'll call this yellow. So those are two colors. But then there's a gray. But this looks yellow, like a gray yellow, and that looks like a gray violet. Or maybe it looks like the same color as that. Because this looks yellow and that looks violet, those are examples of optical color. But do you see how these lines are connected down here and how they go back up? If you were to zoom in really close, you would see that the local color is neither violet or yellow. The local color is a generic gray. But that gray looks different because of the surrounding field that it's in. The surrounding fields really do have the power to change your perception of a color. Okay, I want to describe these two paintings with you, or it's a single painting, or a single artwork, but two canvases. I want to describe this with you. Well, I see them as being warm colors, both of them. This one is more saturated, has a higher saturation than this one. Saturation meaning how vivid the color is. I would say that if you were to think of the value pattern or the value, you have a low value contrast between the top and the bottom here, but you have an even lower value contrast between the top and the bottom here. So this painting is less saturated and has a lower value contrast. Arbitrary color. Arbitrary color does not accurately reflect visible reality. Artists use arbitrary color for purposes other than realism, such as conveying emotion. Color can be used for all kinds of reasons, and they don't have to match the real world. Perhaps the arbitrary color is there to convey emotion, warmth, coolness, but it doesn't have to reflect the real world, such as this painting. I think that the artist Matisse in this painting, I don't think he really cared much about portraying this woman in reality. He was interested in using color in the way that he wanted to. Okay, that is the end of chapter 3. When you're ready, please watch chapter 4 and then take the quiz. The quiz will be on both chapters 3 and 4.